Hey guys, let's do this. So this is the study guide, and I want to give you a little background. Now yours probably, I didn't bring one home with me, but your probably had it has some markings on here about just do the circle questions. And I assigned for periods, what was it? Periods 3 and 7. I asked you to have this to me and bring in by Wednesday. I'll be looking at just page 1 and page 2, the circled ones. Now I'm not sure which of these I circled, but I think mostly everything on the front I circled, and some of the questions here on this second page. I think I had said a couple of these, but not all the other ones. But anyway, let's get to it. So trig functions. Now we've been working on these in class and hopefully you've enjoyed them. Some students have said they're really working well on these. It says write the sine, cosine, and tangent ratio. So all that means is set it up. So sometimes this tricks students on tests because they think they want it to be solved. And all this question is asking for is write it and set it up. Okay, so I think I said to make room down here because you kind of need some room here. So if I'm going to write the sine of angle y, so the sine of angle y is, well, the formula is the sine of angle y is opposite over hypotenuse. So the sine of angle y is, let's label these sides. Okay. So the sine of angle y is 3 over the square root of 3. Oops, we're starting to learn we can't leave our answer like this. Okay. Ugh. So we're going to rewrite it, but I think on a test I would take that. But technically we should be working toward not leaving our answer. So if I took the square root of 13 and multiplied it, that'd be multiplying it by 1 because the square root of 13 over the square root of 13 is just 1. But now the denominator turns into the square root of 13 times the square root of 13 would be this square root of 169, and that's just plain old 13. So the denominator turns into regular old 13, and I get this. Okay, so that is the sine of y. The sine of y is this ratio. Okay, what's the cosine of angle y? So the cosine of angle y is, so the cosine of angle y would have to be adjacent over hypotenuse. So the cosine would be adjacent over hypotenuse. So the cosine of angle y would be 2 over the square root of 13. Once again, I would accept this on the next test, but I'd really like it if you could follow the rules, which like us to rewrite it like this. The denominator turns into 13 and the numerator turns into 2 times the square root of 13. Okay. So again, they just are asking for these ratios here. So they're not asking for you to turn them into decimals. Now last they said find the tangent of y. Okay, so the tangent of y would be opposite over hypotenuse, opposite over hypotenuse. So the tangent of y is 3. Oh, what am I doing? That's a typo. Hopefully one of you caught that. Okay, tangent is opposite over adjacent. Okay, so tangent is opposite over adjacent, 3 over 2. There you go. So I'm not solving for angle y. I'm just writing the ratio that the tangent of y is equal to. Now the directions say write the sine, cosine, and tangent for angle y and for angle z. So now let's switch to angle z. But I keep flipping back and forth. So I'm just going to draw a new picture down here. And there's another reason I'm doing this. Now my reference angle is angle z. So I need to find the sine of z, the cosine of z, and the tangent of z. That's what the directions asked for. So angle z, this now would be the opposite, and this would be the adjacent, and this is still the hypotenuse. Okay, so kind of copying down my problem from up top. Now, notice hypotenuse label doesn't change, but the opposite and adjacent labels change because now my reference angle is z. So if my reference angle is z, sine of z would be opposite, which is 2, over hypotenuse square root of 13. We'll come back and deal with that. Cosine. Cosine is adjacent over hypotenuse, so 3 over square root of 3, or excuse me, square root of 13. And then the tangent would be opposite over adjacent, so that'd be that. So, interestingly, you see how there's a little bit of a pattern here. If I switch the reference angles, the tangent flips over, or is the reciprocal. Now, let's rewrite these. These should be the same, but different. Notice the cosine, the sine of y, happens to be the cosine of z. Notice those were the same thing. So if this simplifies to that, this one will also simplify to that, because those are the same number. All right, similarly, this 2 over the square root of 13, cosine of y is equal to the sine of z. And this simplified to that, so I agree. Okay, now, the next question is asking, now do it to this other one. So hopefully now that you saw what they're looking for on the first part of question 1, you can do it to the second one. So I have to find the sine of y, the cosine of y, and the tangent of y. Okay, so the sine of y is, if this is my reference angle, so if this is my reference angle, this is opposite, hypotenuse, adjacent, right? So the sine is opposite over hypotenuse, 4 over the square root of 65, which we know we're going to have to rewrite 4 times the square root of 65 over 65. These are the same value, it's just written in a different way. The cosine would be adjacent over hypotenuse, so 7 over the square root of 65. So rewritten 7 square root of 65 over 65. And last but not least, tangent. So tangent would be opposite over adjacent, so tangent would be 4 over 7. Okay, we've written out the ratios. Now let's do a different reference angle Z. So that's a different reference angle. So if this is my reference